Hey guys, this is 15.4. We're going to talk now about the last homologous series that you need to be aware of. So one homologous series are alkanes. The other one, the second one we talked about in the last video was alkenes, and the third one is alkynes. Now notice on table Q, right, where all the information, where you should be looking for this to kind of help you and know where it's at, to help with naming. Table Q, even guys at the top, the title says homologous series of hydrocarbons. Remember, homologous just means same. So they're same families. Excuse me. Alkanes are saturated, meaning they're all single bonds. Alkenes have a double bond, and they're unsaturated. Alkynes now, they're also unsaturated, which means, again, they have multiple bonds. Aliphatic, again, straight, chained. Okay, so they're all in one long line, versus aromatic, which are kind of circular, where they're kind of all connected. Alkynes, guys, have triple bonds. That's the last one. So alkenes have a double bond, alkanes have a single bond, and alkynes have a triple bond. All right, think about it in terms of alphabet. All right, A comes first, it's got one. E comes is second in the list of alphabetical order. That's got two bonds, and Y is last, so it's got three. If that's some easy way, I literally just thought of that right now. I've never said that before to students, but that might be something to help you remember it. Alphabetical order, numerical order. The general formula for alkynes, CnH2n minus 2. All right, so there's less than 2 times as many hydrogens as there are carbons. Up until this point, we've had more hydrogens and carbons in alkanes. We've had the same or double the amount in alkenes, and this is less than double the amount. All right, and it's because of that triple bond. They end in the word or the suffix "-ine", and then remember, just like alkenes, that N in the beginning tells us where the triple bond is. Okay, so we have to identify where the triple bond is if there's more than one location for it. Okay, so N is only if the molecule has more than 3 carbons. If there's 2 or 3, all right, there's only one possible option and place for it. So if we take a look here at this first example, right, notice how, 3, well, whether I had the triple bond here or if I moved it over here, then these other H's would shift. All right, it's still only one location. So again, start with counting up how many carbons you have. 1, 2, 3. I've got 3 carbons, so that should be, you should be thinking, okay, what's my prefix for 3? Well, look on table P. Table P has got all of our prefixes for us, so we don't have to memorize them. So 3 would be prop. Now again, I see a triple bond. All right, triple bond means it's an alkyne, so this is going to be called propyne. All right, propyne. That's it. Because there's only one location, we don't need to put the number for where it could be. There's not 2 locations that the triple bond could take place. Let's go over here. Try this one on your own if you feel comfortable, guys. Again, you see a pattern, right? Very similar process. The only thing that's changing is the ending. All right, it's really the only thing that's changing with these. So identifying what that is. And again, you have table Q to kind of show you what that is. And it gives you examples, structural formula examples. It gives you the name examples. It gives you the general formula. So it makes it very easy. You just have to get familiar with it to be able to practice that and get comfortable with it. I know the hardest part is going to be the chains that are branched off of it. So that's where we may need to practice some more. All right, anyway, I've got 4 carbons. My prefix for carbon, all right, is bute. But now, because there's more than 2 carbons, I could have the triple bond here, or I could have it at the end, so I have to label where that triple bond is. So this is going to be on the 1, 2, 3, 4. Doesn't matter if I start there or go the opposite way, same thing. This is 2-butyne. Okay, butyne, because it's a triple bond, it's an alkyne. Again, you only need to include a number for multiple bond when there's more than one possible location. Same thing with alkenes. So I want you guys to pause the video right now and try these 3 examples on your own. All right, remember, it's similar to alkenes. The only thing is, hey, now the end is "-ine". That's it. Okay, so try it on your own first. All right, so 1, 2, 3, 4, 5, 6. I've got 6 carbons. My prefix for 6 is hex. So maybe you kind of want to maybe start with your long chain. There's multiple ways you can do this. Now, if I want to start with my long chain, I'm going to call this hexyne. all right, because it's a triple bond. It's got 6 carbons. Well, just don't forget that, hey, you got to identify where the carbon is, or excuse me, not the carbon, where the triple bond is. So label 1, 2, 3, 4, 5, 6. This is another one where it's in the middle, so it doesn't matter which end you label from. The big thing is you got to remember that you label to where the triple bond is going to be in the lowest numbered carbon. But again, if it's in the direct middle, it doesn't matter which side you start from. So this we would call 3-hexyne. All right, 3-hexyne. Example number 2. 1, 2, 3, 4. Now, this one, it does matter where I label my carbons because the triple bond is on the end. I need it so that it's on the least numbered carbon. So this would be 1, and then 1, 2, 3, 4. I've got 4 carbons. 1-butene. Okay. Notice this example, guys, here, example number 2, and this one up here, right? They're both butene, but what's different about them? Oh, the triple bond's in a different location. In the next video, we're going to talk about what these things are called, and they're called isomers. Same formula, different structure. Anyway, we'll get more into that in the next video. Last one. Oh, they give you the name now, so you just have to write it. So, guys, one thing I want to point out, with the name, the best way to kind of go, going from a name to writing the structural formula, start with your longest chain, okay? Get that set up first and then worry about the other pieces. So pent, right, that prefix pent means I have 5 C's. So I'm going to draw those in first. 1, 2, 3, 4, 5, okay? So I've got 5. Do you see any chains coming off of this? Nope, because it's a straight chain. Okay, so I don't need to worry about that. So now I've just got to figure out, okay, well, what type of bond do I have? Is this an alkane, an alkene, or an alkyne? Well, look at the suffix, right? That Y means it's an alkyne, so it's a triple bond, and it's at carbon number 2. So I can label carbons. It doesn't matter which side I start from. All right, 1, 2, 3, 4, 5. I'm going to throw in my triple bond at the second carbon. If you labeled yours the opposite way, guys, then your triple bond would go with that carbon. Okay, in between those two. Same thing. Last step, though, is make sure you show your hydrogens. And think about this, guys. How many bonds can each carbon have? 4. So if it doesn't have 4 lines to that carbon, then fill it in with hydrogens. So that's why I put 3 around this guy. Will this guy here take any hydrogens? No, because it's got 1, 2, 3, 4 bonds already. Will this guy take any hydrogens? No. 1, 2, 3, 4 bonds already. This guy needs 2 more, and this guy needs 3. Okay? So as you're going from a name to a formula, I think that's probably might be easier for people is to go from a name to a formula, but you've got to be able to go and be able to do both. All right? So, continuing on, guys, branched alkynes. Same idea that we've been doing with the alkanes and the alkenes, except now, again, you just have a triple bond in there. The branch prefix name comes first. The parent chain comes last, along with the number of where the double bond, again, this shouldn't be double bond, change this because this is alkynes. Triple bond is located, okay? So, name. I'm going to start with my big chain first. So that's pent. So I need 5 carbons. 1, 2, 3, 4, and 5, okay? It says 3-pentyne. Notice here, though, okay, my branch chain gets named first, so the numbers correspond to that. So that means I'm going to have, if I label my carbons, doesn't matter right now where I label them, 1, 2, 3, 4, 5, I have 2-methyl. So that means off carbon 2, I have to have a methyl group. Remember that prefix meth means 1 carbon, so fill it in with hydrogens around. And then my triple bond is on carbon 3, right there. Okay, now I'm going to fill in with other carbons, with other hydrogens, 1, 2, 3. This guy needs just 1 more bond. These guys are good because they've got that triple, and then this guy needs it there. So there would be 2-methyl 3-pentyne. Okay? I encourage you guys to pause the video and try to do the rest of these examples on your own. All right, moving on. So, going from a formula to a name. So you've got to figure out your longest chain first. So start counting it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I see this way. If I do anything else, 1, 2, 3, 4, 5, 6, 7, 8. Nope, that's not going to get the job done. 1, 2, 3, 4, 5, 6, 7, 8. Nope. excuse me, so 9, guys, this path right here is my longest chain. Okay, so I'm going to start with that. All right, along this, I've got my prefix non, and the ending is going to be "-ine" because there's a triple bond in there. So now start kind of going through. Let's label. Either way, it's going to be the same thing, okay? Because this is a symmetrical looking molecule. All right. So I'm going to start over here on the left. 1, 2, 3, 4, because that's where it's going to be the least number of carbons for my triple bond. 5, 6, 7, 8, 9. All right, so that means I have a branch right here, and I have a branch right here. Well, I'm going to get my ending part taken care of. You might want to do your branch groups first. That's fine. There's multiple ways you can do this. 1, 2, 3, 4. So it's 4th carbon. So this is going to be 4 nonine. Okay? Because of that triple bond, we're labeling that. Now we can do the branch chains. So I've got a branch chain off of carbon 3, and I've got a branch chain off of carbon 7. They're the same branches, right? 1 carbon each. So that's going to be methyl. But if I have 2 of the same, what prefix do I need? Di, right? So this is 3,7 dimethyl 4-nonine. Now, do I anticipate them giving you something like this on the Regents? I would be shocked, but they could. So again, it's the same process, guys, for alkanes, alkenes, alkynes. Label your long chain first, and then worry about any branches that you may be coming off of, okay? So try these last few examples on your own, okay? Butane, starting with that first because it's my long chain. That's 4 carbons, all right? 1 butane, so that means my triple bond's going to be at carbon number 1. So this is 1, 2, 3, and 4 based on where my triple bond is. And I need a methyl group coming off of carbon 3. Bam. And now fill it in with hydrogen. So this carbon needed 1 more. This guy's good. This guy needs 1 more, and this guy needs a few more as well. So that's what our 3-methylbutane would look like. Another way you could draw this, guys, is like this. Remember, you could see it where they don't show all the different atoms. Okay, if it's just something like that. That's a little bit more advanced. So my encouragement for you guys is to do this right here. Okay. But you may see in my answer key some of both, like I said before. All right, example number 4. Hex. I'm starting with that first, so that's 6. 4, 5, 6. 2 hexynes, so label your carbons the way that you want to label them. Oops, 5 comes after 4. Man. 2 hexynes, so that's 1, 2. Bam, there's my triple bond. Now I need a 4. I need a methyl group coming off of the 4. Like that, and then fill in with hydrogens. Those 2 guys are good. This guy needs 1 more, 2 more, 3 more. Okay, we could have also flipped it around. That's okay. And the last one, heptine. So that's 7. 1, 2, 3, 4, 5, 6, 7. So 5 heptine to, oh boy, 4, 5, 6, 7. So I need a triple bond at carbon 5. And this is going to be 2, 3 dimethyl, so 2 methyl groups coming off of it. Okay, and then fill it all in with hydrogens. Guys, it takes practice. You've got to be able to know the difference between all 3 series. But you have table Q, you have table P. You don't have to memorize prefixes. You don't have to memorize formulas. Okay. You don't even have to remember how to necessarily identify alkane, alkene, alkyne because they give you pictures. But you've got to know the basics of naming. So do your long chain first, label carbon numbers, and then worry about branches after. So continue on. This is where we have a practice now where it's all mixed together. All right, so make sure you spend time doing practice 2. If you feel you need extra, check the extra practice binder for more practice sheets as well. Till next time, I'll see you later.